The iconic Mount Rushmore is a marvel that seems almost natural in its formation, as though it emerged from the mountain itself rather than being the result of human craftsmanship. However, the truth is that Mount Rushmore is both a work of art and an engineering masterpiece. Created by a team of gold miners with no artistic experience, the monument came to life using jackhammers, dynamite, and ingenious engineering techniques. The design was mapped onto the mountain using methods inspired by ancient Greek technology, and remarkably, the entire process was completed without a single casualty. But to truly understand the existence of Mount Rushmore, we must first look back in time. The vision behind Mount Rushmore. In the early 1920s, South Dakota, still a relatively new state, faced challenges in establishing itself. State historian Don Robinson noticed the surge of tourists visiting a new sculpture in Georgia and was inspired to create something similar. He contacted sculptor Gutzon Borglum to propose a monumental sculpture of America's Wild West heroes. While Borglum appreciated the idea, he suggested featuring national figures like presidents to attract greater attention. In 1925, Borglum traveled to South Dakota, discovering Mount Rushmore, a 500-foot granite cliff he deemed the perfect blank canvas. After securing the mountain, he studied presidential photographs and created a 1/12 scale model. With his vision set, the next step was figuring out how to realize the project on such a massive scale. Borglum's master plan. At the time, Mount Rushmore was entirely undeveloped, lacking roads, electricity, or access for workers. By 1927, a road was constructed to transport goods and workers, and soon, a small village formed at the mountain's base, complete with tool shops, blacksmiths, and worker housing. An enormous staircase led to the mountain's summit, while a cable car transported materials and tools. A winch house at the mountain's peak allowed operators to lower workers on small seats to carve specific areas of the cliff. With infrastructure in place, the team began their first major task: carving the head of George Washington. Carving George Washington. Using dynamite, workers removed large chunks of rock to create a rough, egg-shaped head. From there, they used 30 kilograms jackhammers to refine the features, a challenging task given the precarious conditions. To power the jackhammers, 3 massive air compressors, fueled by electricity from a nearby gold mine, were installed at the mountain's base. Compressed air traveled through a 2,000-foot pipeline up the staircase to a mountaintop station, enabling up to 16 jackhammers to operate simultaneously. Workers developed unique techniques to stabilize their tools, using chains for grip or even guiding the jackhammers with their feet. Despite having no artistic training, they became skilled in operating the machinery. But how did they know where to carve? On a previous project, Borglum had used a projector to map his designs onto stone, but Mount Rushmore's scale and the three-dimensional nature of the faces made this impractical. He needed to devise a new method to accurately transfer the details from his model to the mountain. Mapping Mount Rushmore. To turn his vision into reality, Borglum employed innovative techniques to map the proportions and details from his 5-foot model onto the 60-foot cliff face. This meticulous process ensured the accuracy and grandeur of Mount Rushmore, solidifying its place as an extraordinary feat of art and engineering. Much like the details of Mount Rushmore, can be precisely mapped, but not always for good. Mount Rushmore, much like safeguarding personal data, required innovation, resilience, and vision. Its creation is a testament to human ingenuity and determination. Borglum took inspiration from ancient Greek techniques used to replicate Roman statues, specifically the pointing machine. This tool allowed artists to measure specific points on a sculpture relative to a reference point and transfer these measurements to a different medium, guiding the carving process. By mapping thousands of points, an exact replica could be created. However, while this method worked for sculptures of the same size, scaling up Mount Rushmore required ingenuity. Borglum devised his own version of the pointing machine, a large metal arm with a weighted point that swung around a fixed axis. By placing the point on his 112 model, he could measure the angle, horizontal distance, and vertical distance of a specific spot. Multiplying these measurements by 12 allowed him to scale them up accurately for the mountain. To apply this, Borglum built a massive pointing machine atop Mount Rushmore. Borglum's pointing machine was a groundbreaking invention that made the meticulous task of carving Mount Rushmore possible. This larger-scale version of a traditional pointing device allowed workers to mark thousands of precise points on the mountain's surface. These points indicated exactly where to drill and how deep to go, ensuring the accurate transfer of measurements from Borglum's 1/12 scale model to the massive cliff face. Instead of carving out large sections of rock at once, the workers employed a honeycomb drilling technique. They drilled a grid of closely spaced holes and then hammered out the rock between them. This method was efficient but required extreme precision and effort. The labor was physically demanding and hazardous. Workers spent 8-hour shifts suspended 500 feet above the ground, supported only by harnesses and cables. They operated heavy jackhammers, which were powered by compressed air pipe from a compressor station at the mountain's base. These tools weighed approximately 30 kilograms, adding to the grueling nature of the work. After hours of drilling, steel workers would descend to deliver replacement bits, ensuring the work continued without interruption. For all this effort, the laborers were paid a mere 50 cents an hour, a modest sum even for the era. Despite the challenges, progress on Mount Rushmore was steady. The team successfully completed George Washington's head after several years. Once this major milestone was achieved, Borglum shifted his focus to refining the finer details of the sculpture. One of the most intricate tasks was carving the eyes. Unlike traditional Greek statues, which often featured smooth, flat eyes that appeared lifeless, Borglum devised a method to make the eyes of the presidents appear more dynamic and realistic. He carved a deep hole for the pupil to ensure it was always shadowed, creating depth. At the center, he left a small square section uncut to act as a reflective highlight, simulating the shine of a real eye. This technique was both risky and revolutionary, as the rock could collapse under its weight at any moment. Once the faces were carved, the final step involved a process called bumping. This method smoothed the surface of the sculpture, brightened the granite, and gave it a polished, white appearance. After 14 years of relentless work, the team had achieved remarkable progress, but Mount Rushmore remained unfinished. The original vision for Mount Rushmore was far more ambitious. Borglum had planned for each president to be carved down to their waists and intended to create an ornate, secret tomb within the mountain. However, World War II drew attention and funding away from the project, halting its progress. Shortly after, Borglum passed away, leaving the grand vision incomplete. Despite its unfinished state, Mount Rushmore remains an enduring symbol of American history and engineering ingenuity. Borglum and Doane Robinson succeeded in their goal of putting South Dakota on the map, creating a monument that attracts millions of visitors and stands as a testament to human determination and artistry.